Good morning. Last time I recorded or made a video with the DC motor with an inverter board. Today I am going to describe how we can use the dSPACE or work with the dSPACE with the three-phase induction motor. So as you have already know from my previous video that we have four parts for the dSPACE. One is like one board that is inside this board, inside the CPU. Second one is this is the dongle file. This is the license file for the dSPACE. Third of all, we have interference board. This is called a CP1104, and fourth one is the software. This is called the control desk for the dSPACE for controlling everything and for monitoring everything. So today I'm gonna describe this big inverter unit. This is a three-phase inverter. It has 6 switches over here. That is for the three-phase. So per phase it actually works with 2 switches, and we have three-phase input over here for the inverter board, and three-phase output from here, and this some internal connection for the inverter. And we have so let me explain this one first. So this one is a voltage regulator circuit. It actually we have in the dSPACE it can only generate 5-volt supply, but for this thing to work with it needs 15 volt. So this circuit actually boost up this 5 volt to 15 volt. This is the switching signal for this inverter unit. So, and here we have the three-phase supply for that inverter, and this is the three-phase, and this is the neutral connection. This goes directly to the inverter board, and we have a fuse to safely operate everything. So now I'm going to describe how we are working with the Simulink model and the dSPACE. So here this is the Simulink model which is designed for working with this one. We have this after build I have already told you that after building that one, this Simulink model, this will generate a SDF file. That SDF file is going to be read by control desk, and through control desk it will operate everything. So it's basically a hardware in the loop, where there is a hardware, that means the induction machine or induction motor, that is works with the loop of a software to control and monitor and optimize everything. So one thing I want to explain, I want to add that as in the lab we don't have any portable or small size of induction machine, so I'm going to use this variable resistance as a induction machine, and we are going to see the output in this oscilloscope. Okay, so I have already told you here's the Simulink model, and here is the control desk. I have already built it, and it's read by control desk, and this is the control desk layout file, and this is the AC source. So, and that one is the oscilloscope output. So if you come closer, if you just lower this volume, then you can see that in the oscilloscope that there is no signal. This is the pulse for the switching. I have only shown the one pulse, but if it is actually having the 6 pulses, so when the one switch is on, the other one is off. It operates like this way: one on here, and one on here. So other switches are off. So this is the switching pulses. This is 15 volt, and if I going to increase this one, you can show over there that the output is going to be the changing. It's like with the pulses we have the output, and without we don't have the output where there is no pulses. So it's basically I'm measuring the one phase to neutral, and it has like 3 phase, so 3 phase to neutral and everything. So it will operate like this way. We have the manual, and we have the Simulink model added to this upload. So there you can just know everything and go through briefly everything. Thank you so much, and have a good night. Okay.